Question number 37, we are asked to find the gradient of the curve 2x squared plus 5x minus 1 at a point where x equal to 4. So you have to differentiate the function first, dy over dx, applying power rule. The power will drop down to multiply. We have 2 times 2 is 4. Then x raised to the power of 2 minus 1, which is still 1. Then plus derivative of 5x is 5. Derivative of constant is 0. So all you have to do is to plug in x equal to 4 here. So we have this to be 4 multiplied by 4, then plus 5. 4 multiplied by 4 is 16, and 16 plus 5 is equal to 21. So it is option E. Let's move on to question number 38. An interior angle of a regular polygon is 108 degrees. Find the number of sides of that polygon. So if a polygon is regular, it means all the interior angles have the same measure. If it is 108, all the other angles will have the same measure, 108. So what can you remember about our regular polygon? To find the measure of every single angle in a regular polygon, you can always take the formula, which is n minus 2 multiplied by 180 degrees divided by n. This will give you the measure of every single angle. But we are giving it as what? 108, so we equate it to be 108. Let's cross multiply and expand the bracket. N multiplied by 180 is 180n. Then minus 2 times 180 is 360. And this is equal to n multiplied by 108 is 108n. Let's collect the like terms. We have 180n. If this crosses over, it becomes negative 108n. If you take 360 to the other side, it becomes positive 360. If you subtract this, you're going to have 72. 72n equal to 360. Divide both sides by 72, n is equal to 360 divided by 72, and n is equal to 5. Therefore, that regular polygon has 5 side lengths, which is option B. Question number 39 reads, ABC is an isosceles triangle where E and D are points on the sides of AC and BC respectively, such that line BE is perpendicular to the line AC and line ED is perpendicular to the line BC. If angle ABE is 68 degrees, where angle A is equal to angle C, we are asked to find the measure of angle CED. I've already constructed the diagram here. Let me show you everything. It is a triangle ABC according to them. And we have 2 other points, E and D, that lies on the sides of AC and BC respectively. So you can see a point E here on the side of AC, and you can see that D is on the side of BC. And it's stated that if you draw a straight line from B down to E, you can see I have done that, B down to E, it will be perpendicular to the line AC. And you can see line AC here. What does it mean to be a perpendicular? They will meet at a right angle, which is 90 degrees. So this angle right here is 90 degrees. And if you draw a line from E down to D, it will be perpendicular to the line BC, which is also 90 degrees here. So we are asked to find angle CED. You can see this is C, this is E, this is D. So we are referring to this particular angle. Let me mark it. This particular angle is what we are looking for. All right, let's concentrate on this right angle triangle, because you can see that we have a right angle here. It means it is a right angle triangle. So what will be the measure of this angle? Already, the question stated that angle A and angle C are exactly the same. So I don't think we even need to find the measure. Let me just call it X. And this must be X because it is an isosceles triangle, right? And we have learned that in a right angle triangle, the two other sides added to 90 degrees, right? Because 90 plus 90 will give us 180. So just observe something. We have angle X here. We have angle 90. We have angle X. We have angle 90. Which means that this missing angle must be 68. Oh, so the two triangles are congruent to each other. So this is 68. We don't have to calculate for anything, unless if you wish to do that. So it is 68, which is option E. Now let us move on to question number 40. Question number 40 reads, in the figure below, O is the center of a cycle. We're asked to calculate the measure of angle X. And you can see that right here. So let me zoom it a little bit so that you see everything. First of all, you should consider this. What's this? This is a triangle, right? Just observe there's an extension here, which means that this angle, if we should find this angle, it is going to be an exterior angle of that triangle. And remember, exterior angle of a triangle is equal to the sum of the two interior opposite angles, which implies that if we should add 34 and 40 together, it will give us this particular angle shaded red. So let's find the angle. So 34 plus 40 will give us 74. So this particular angle is 74 degrees. And what do you think of this angle? They are directly opposite, right? So if this is X, this must be X. So let me call this X. We're moving. All right, remember one theorem which stated that angles subtended to the circumference from the same chord are exactly the same. So look at a chord here. This is a chord. It subtends an angle to the circumference, which is 40. And you can see the same chord subtended an angle to C. So this means that angle C must be 40 as well. All right. So this is 40 degrees. So we are almost done. Remember, we are looking for X. Therefore, the sum of these three angles must be equal to 180, which implies that X is equal to 180 minus 74 minus 40. And this is equal to 66 degrees. Which option is that? Option B. Now let us move on to question number 41. Question number 41 reads, in the diagram below, O is the center of the cycle. The length of line BD is equal to the length of line BC. Already they have marked it, you can see, which means that this particular triangle is an isosceles triangle. All right. And the ABC is 54 degrees, this particular angle here. We are asked to find the measure of the angle ACD. So this particular angle, let me mark it. This is what we are looking for. All right, let me zoom it a little bit. Let's call this X. Let's call this X because the base angles of an isosceles triangle, they are always the same. And you know that the sum of these three angles must be what? 180. Therefore, 2x must be equal to 180 minus 54, right? And x is equal to 180 minus 54 divided by 2 if you divide both sides by 2. So let's find the value of x. The value of x is 63 exactly, 63 degrees. All right, you should remember another cycle theorem which stated that diameter of a cycle sustains an angle of 90 degrees to the circumference, which means that the entire angle here is 90 degrees. But we already have an x which is 63 degrees. So 63 plus that missing angle that we are looking for, let me call it y. X plus y must be equal to 90 degrees according to the theorem. But x is 60, therefore y is equal to 90 minus 63. 63, right? And 90 minus 63 is 27 degrees, which is option E. Now let us move on to question number 42. All right, question number 42, we are asked to determine the value of 7x in the diagram below. So you can see because of this mark, it indicates that this is an isosceles triangle, right? And the base angles must be the same. So let's start by filling in the angles. This angle and this angle, they are exactly equal because they are opposite. So this is 2x. And because the base angles are the same, this must be 2x. This angle is also directly opposite, so we call this 5x. And the sum of these three angles will give us 180. So what do? We say that 5 plus 2 is 7, 7 plus 2 is 9. So we have 9 x's equals what? 180 degrees. Divide both sides by 9, x is equal to 180. Divide by 9, and x is equal to what? 20 degrees. So x represents 20 degrees, but we are looking for 7x. Therefore, we can multiply both sides by 7. 7 times x is 7x equals 7 times 20 is 140 degrees. Therefore, 7x is 140, which is option E. Now let us move on to question number 43.